this module, Introduction to Geothermal Fundamentals, I would like to talk with you about heat pump technologies. And in this module, we'll take a look at heat pumps. Why do we need them and where are they coming from? What different heat pump technologies can we find on the market? And then we'll take a little bit more detailed look at the workhorse of ground source energy systems, the vapor compression cycle, after which we'll discuss efficiency, theoretical efficiency, Carnot, and then more practical coefficient of performance and energy efficiency ratio. We'll round off with some key points for the application of heat pumps. So what is a heat pump? Basically, or essentially, a heat pump is a refrigerator. A refrigerator also creates a cold zone on the inside and rejects heat on the back. So that's what a heat pump does. Basically, it pumps heat from a low to a high temperature. Why do we need them? Well, if we look at the emission system, the user side, then we can see that for heating with radiators or for domestic hot water production, we need temperatures between 55 and 70 degrees. For heating with underfloor heating or cooling with underfloor heating, we'll need temperatures of around 35 degrees for heating and 20 degrees for cooling. For dehumidification in air handling units, we would need around 8 or 10 degrees. If we take a look at what we can get from the ground, what we can expect, kind of temperatures that we can expect from the ground, we can see that, for instance, in Scandinavia, after a long winter, 30 years of operation, the ground temperature may be down to -5. Whereas in the south, after 20 or 30 years of operation and a lot of cooling in summer, the temperatures may rise to around 30. So essentially, the temperature that we can get from the ground and the temperature that we need in the system on the user side are not the same. And we need a heat pump to either increase or lower the temperature. Different type of heat pumps exist. They've been around for quite a long time. The first ideas about heat pumps have been around since 1748. In 1948, we see the first ground source heat pumps realized. And then in the 80s, we see a lot of activity, especially in Scandinavia, where a lot of fundamental research has been done on the design of ground source heat pump systems, and also the implementation really started. Nowadays, they're considered to be one of the most environmentally friendly ways of heating and cooling due to their high thermal efficiency. This means that we can save a lot of primary energy, we can save a lot of CO2 emissions, and we can save a lot of money because we need to buy less energy for heating and cooling. Different methods of the heat pump exist. For instance, a vapor compression heat pump, absorption heat pump, and more recently, an acoustic heat pump. Now, the workhorse of ground source energy systems is the vapor compression heat pump. So we'll take a closer look at that particular technology. Before we go into the cycle itself, we need to consider sources and sinks. Here in the diagram on the top right, you can see on the right a hot sink and on the left a cold source. And the heat pump transfers heat from this cold source to the hot sink. Obviously, we can use both sides. If we want to cool the building using the heat pump, we can use the cold source and reject heat to the ambient on the condenser side on the hot sink. And the other way around, if we want to heat the building or domestic hot water, we can use the hot sink and connect the cold to the source, to the air, or to the ground to extract heat from the ambient. Different sources and sinks can be used. We can think about air, waste heat. We can think about surface water, but obviously for shallow geothermal energies, we're thinking about groundwater, open loop systems, and the ground itself in closed loop systems. And actually, it's possible to have a dual source heat pump that uses either air or other sources and the ground, depending on where we get the highest efficiency, where we get the best temperature for the heat pump itself.